Lesson 1, experimental versus theoretical probability. So probability is the likelihood that something happens. And the way that we determine it is we take the number of times an event can happen, and we take the total number of trials, or how many times it's possible to happen. And the way that we express it is in 4 ways. So the first way would be a percent, so we could write it as 50%. Another way to write this would be a fraction, which would be the same as 50 out of 100. It would be the same as 5 out of 10, or 1 out of 2 as well. All of those fractions would get you the same probability. As a decimal, you would divide those numbers to get 0.5, and as a statement, we would write it as 5 out of 100. So determining probability, you want to try to find out how many times the event is likely to happen and the total possible number of outcomes. So for example 1, Shelley works at a store that sells light bulbs, and she finds that the current shipment has a high number of defective light bulbs. Shelley decides to test how probable it is that the light bulbs from the assembly line are defective. She has workers on the assembly line randomly choosing light bulbs from the assembly line to test them. Out of 265 light bulbs, she finds that 2 were defective. So this is the event that's happening, and this is the total outcomes that were sampled. So to figure this out as a percent, a decimal, a statement, and a fraction, we can start with a fraction. So this is the same as 2 over 265. And the way that we would say that is 2 out of 265. So there's a fraction and a statement. To find a decimal, you divide 2 divided by 265 to get 0.008. And to make that into a percent, you can times this by 100, or move the decimal over twice to get 0.8%. So there's a 0.8% likelihood that a light bulb is defective. So in a shipment of 5,000, how many light bulbs are likely to be defective? So you can do this in 2 ways. We know we have 2 out of 265 are defective. We want to figure out how many out of 5,000 would be defective. So we set up a proportion and put an X in the defective part, and then you're going to cross multiply and divide. And this is the same as taking 2 divided by 265 as a decimal, which we already know is 0.08, and multiplying by 5,000. And you should get 40 light bulbs. So this is a good example to show the difference between experimental and theoretical probability. So theoretically, there should be 40 defective light bulbs, and that's judging by the test that they did from the assembly line on a smaller sample size. If you were to actually go and test all 5,000 of those light bulbs and actually find how many were defective, that would be more experimental probability, because you're actually finding the real outcomes, not what your formula, I guess, would tell you. So this is based on a calculation. This would be based on an action. So there's 2 differences between the 2 of them. Example 2. The following is a spinner with different colors on it. Determine the probability that the spinner will stop on a green space. So in total, there are 10 spaces. There's 2 greens. So our event would be 2 out of 10, which is 20%. So there's a 20% chance that you will land on a green spinner. And of course, this is theoretical probability. If you were to spin the spinner 10 times, you should hit green twice, but that doesn't always happen. B, determine the probability that the spinner will not stop on yellow. So if it's not yellow, that means it's any other color. So that would be 8 out of 10, because there's 2 yellows, which is 80%. So there's an 80% chance you won't hit yellow. Determine the probability that the spinner will stop on a red or an orange space. So that would be here, 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 or here. So that's 4 out of 10, which is 40%. So you're going to add both those events together, the 2 oranges plus the 2 reds. A bag of finishing nails contains 5 nails measured 1 inches. It has 5 nails measuring 2 inches, 7 nails measuring 3 inches. Determine a carpenter randomly chooses 1 nail and does not replace the nail. He then takes a second nail. What is the probability that the first nail would be 1 inch? So first off, we find our total. So altogether, there's a total of 17 nails in the bag, wherever he has these nails. So if he's picking the first nail, the probability of it being 1 inch, so there's 5 in total, so it'd be 5 out of 17. And to find it as a probability, you're going to do 5 divided by 17 times 100, and you should get 29%. B, so this is completely separate now. What is the probability that the second nail, after he chose the first nail, will be a 3-inch nail? So the first event has already happened. Now we're doing the second event. And now, because he doesn't replace the nail from the bag, there's only 16 nails left in the bag. But we're trying to get a 3-inch nail here. So we have a 7 out of 16 chance. So 7 divided by 16 times 100 is 44% chance. So the first time he picks a nail, he has a 29% chance of getting the nail he wants. Second time he picks a nail, he's got a 44% chance. Now for the for the part C, it asks us what's the probability that he will choose the first nail and the second nail together. So now, because we're doing multiple events, what we have to do is we have to take event 1 and we have to times it by event 2. We're timesing our multiple events because when one event depends on the other event, the likelihood of them both happening together gets smaller and smaller. So the first event we know was 5 out of 17, and the second event was 7 out of 16. So we're going to times those two numbers together. So 5 times 7 is 35. And 17 times 16 is 272. 35 divided by 272 times 100 is 13%. So there's a 13% chance that he will pick both of the nails that he wants in that order. You're rolling a dice in a board game and you need to make it to a certain square. You have 2 turns to get to this square. Your 2 rolls need to get a 5 and a 6. So for A, what's the probability of getting a 5 on your first roll? So there's 1 5 out of 6 sides of a dice. So 1 divided by 6 times 100 is 16.7%. Part B, what is the probability that you will roll a 6 on your second roll? Now because it doesn't matter what your first roll had, it doesn't affect this outcome at all. It's still 1 over 6. You still have 6 sides to the dice. So it's again 16.7%. And part C, what is the probability that you will roll a 5 and a 6? So both part A and part B, we have to multiply the events together, which is the same as 1 times 1 is 1, 6 times 6 is 36, 1 divided by 36 times 100 is 2.8% chance. So your chances get lower and lower the more events you add. Example 5, you're drawing cards from a standard deck of 52 cards. You draw the first card, replace the card back in the deck, and pick again. What is the probability of drawing both cards to be a club? So our first event would be you getting a club. So there's 13 clubs in a deck of 52 cards. Now you put the card back in the deck, and we have event 2, and you want this to be a club as well, which is the same as 13 over 52. Our cards haven't changed. We're going to multiply the events together. 13 times 13 is 169. 52 times 52 is 2,704. Divide the top by the bottom, times it by 100, and you should get 6.25%. So you have a 6% chance of drawing 2 clubs. Part B says you draw the first card, then you keep the card out of the deck. what is the probability of both cards to be hearts? So for event 1, there's 13 out of 52 cards to be a heart. And if we got that card to be a heart, for event 2, there's only 12 hearts left, and there's only 51 cards left in the deck. So we're going to do 13 times 12 to get 156, and 52 times 51 to get 2,652. Divide the top by the bottom, times by 100, and you get 5.9%. Part C, you draw the first card to be a 5. What is the probability of drawing the next two cards without replacing any cards on the deck to be both cards higher than 5? So first we need to figure out how many cards are higher than 5, and we're going to assume that ace is a low card. So the cards that are higher than 5 are 6, 7, 8, 9, 10, Jack, Queen, King. So that's 1, 2, 3, 4, 5, 6, 7, 8 cards times 4 suits. So we know there's 32 cards in total. So after we've drawn the first card, we have event 1. We already know there's only 51 cards left in the deck because one of the 5s are gone. So we want to take from this total of 32 cards which are higher than 5 for event 1. And then we want for our second event, we also want this to be higher than a 5. But because we've now taken 2 cards out of the deck, there's only 50 left in the deck, and we're assuming we got a high card after the 5, so there's 31 high cards left. So we times these two events, and we get 992 over 2,550. Divide those numbers and times by 100, and you get 38.9% chance. So you do have a high chance of getting a higher card.